You know, when you picture a live television broadcast, you probably imagine this perfectly controlled studio environment. It is climate controlled, it is soundproofed, and the cameras are just, well, gliding across these flawlessly smooth floors.
Right, the ideal scenario.
Exactly. But then think about what it takes to broadcast a yacht race in the middle of a storm, or maybe a live military exercise. Suddenly, that safe studio environment is entirely
Oh,
gone.
it's totally out the window. And that brings us to today's deep dive. We are looking at a highly detailed product spec sheet for the Bolin Technology EXU230HEX Ultra Array.
Yeah, it is an outdoor pan-tilt zoom camera. And I mean, at a price point of $8,395, it is a serious piece of equipment.
Okay, let's unpack this. Why should you care about a commercial camera spec sheet?
Well, because exploring these specs reveals exactly how extreme engineering is actively solving the chaos of live broadcasting. Like bringing you a crystal clear image from a completely hostile, unpredictable environment is basically a masterclass in protecting delicate tech. So to understand that massive price tag, we really first have to look at the brains under pressure here. The source highlights a Sarviso module featuring a Starvis 201/1.8-inch sensor, pushing full HD resolution.
Yeah, it's 60 frames per second too.
Right. But for anyone not working in video production, what does a Starvis 2 sensor actually do?
Think of it as a sensor specifically designed to pull in light so effectively that it can basically see in near total darkness. And it does that while maintaining a perfectly crisp image. But the real challenge for this camera is the massive 30x optical zoom.
Which is exactly where things get tricky. Using a 30x optical zoom on, say, a bouncing 4x4 vehicle, well, it is basically like trying to read a tiny text message on your phone while riding a mechanical bull.
That is a great way to put it.
Right. Any tiny vibration at the lens becomes feet of wild movement for the viewer. It is just a recipe for instant motion sickness. So how do they actually solve that?
What's fascinating here is the super image stabilization technology. It is not just cropping the video digitally to fake a smooth shot, you know.
Okay, so it is purely mechanical.
Exactly. It uses internal gyroscopes that instantly detect the physical direction of a bump, and then it physically shifts the lens in the exact opposite direction to cancel it out.
Oh, like when you hold a chicken and move its body around, but its head stays perfectly locked in place.
I mean, that is a highly specific visual, but yes,
Yeah.
it is the exact same mechanical principle. Those gyroscopes react instantly, keeping that high-definition feed locked in.
Okay, so the gyroscopes handle the physical bouncing. But how does that delicate lens survive the actual environment? You know, mud, salt water, freezing rain.
Yeah, that brings us to the camera's intense physical shell. The specs show a built-in windshield wiper, a sun shield, and an aluminum housing that is actually filled with nitrogen.
Wait, why go through the trouble of filling it with nitrogen?
Because nitrogen displaces oxygen and moisture. If this camera goes from a blazing hot desert environment straight into a freezing night, normal air inside the camera would condense.
Oh, and it would fog up the inside of the lens.
Precisely. The nitrogen ensures the internal mechanics stay bone dry, preventing any internal fogging.
That is clever. But I do have to question one spec here. It highlights a C5 anti-corrosion standard. Now that is for industrial chemical plants. Who is actually taking a broadcast camera into a chemical bath?
It sounds absurd until we look at the targeted use cases from the source material. We are talking military vehicles and marine environments. Saltwater isn't just water.
Right. It is highly corrosive.
Yeah, it is essentially a chemical bath that rapidly destroys standard electronics and accelerates rust. That C5 rating means this camera can be mounted on a ship's mast, pelted by salty sea spray for months, and the internal electronics remain completely untouched.
So it is wearing this 22-pound suit of heavy-duty armor to keep the salt out. But hold on. If it weighs 22 pounds, how does it track a fast-moving boat? Heavy objects have momentum. They don't just stop on a dime without shaking.
And that is where the motor engineering really shines. It utilizes something called zero deviation positioning, or ZDP.
Okay, how does that work?
Instead of just cutting power to the motor and letting friction stop the camera, which would cause a visible bounce, ZDP uses high-precision stepper motors and continuous mathematical feedback.
So it is actively braking.
Exactly. It calculates the exact counterforce needed to stop that heavy mass dead in its tracks. So you have this 22-pound armored enclosure panning 340 degrees silently with the precision of a watchmaker.
So this isn't just a camera. It is basically a broadcasting tank. The specs say it uses PoE, so power over Ethernet, meaning you only need one standard network cable to give it power and send the data.
Right. It simplifies the rigging significantly.
And it has a 360-degree tally light antenna, so the on-camera talent knows when they're live from any angle. Plus, instead of getting bogged down in acronyms like 3G SDI, HDMI, and IP I'll simply say this.
Let me guess. It can do it all at once.
Yeah, it can simultaneously send high-quality video to a traditional broadcast truck, a local monitor, and stream directly to the internet all at the exact same time.
If we connect this to the bigger picture, this hardware represents a massive shift in media. Pristine, live broadcast quality feeds are no longer confined to safe, static studios. The technology can now go wherever the action is, no matter how brutal the conditions.
Which leaves you with an interesting question to ponder. If a camera can seamlessly output a flawless 30x optical zoom while mounted upside down on a boat in a corrosive, stormy sea, what previously impossible extreme live events will you be able to watch from the comfort of your living room in the near future?